Okay, here's a little demonstration, a little video just on how to find the inverse of a log function. Okay, I hope it helps. First off, it's important to note that the inverse of a log function is always an exponential function. Okay, so your goal when you're done with this would be something to the power of x, some kind of an exponential function. Okay, so the basic plan is to switch x and y and then solve for y. But it's important to note that to solve for y when we've got a log function means you're going to flip it into that exponential form, kind of using that snail idea, just the way the log function is constructed. So let's solve for y first, switch x and y first. So we'll get x equals log base 3 of y plus 1. All right. And then we've got the log function is all there by itself, so we'll just flip it into that exponential form first. Remember, that means we're going to start with the base, and we raise that base to that power, x, and then that gives us this expression here, y plus 1. So what that looks like then is 3 to the x equals y plus 1. All right, now it's in exponential form, and solving for y to finish it up is pretty easy from here. Just subtract 1, and we get 3 to the x minus 1 equals y. And that's our inverse function right there. All right? So it's not so bad when the log function itself, even though that's log base 3 of x plus 1, the log function is essentially all by itself there on the right side of the equation. Sometimes the log function is more complicated. All right, so when that log function is more complicated, and I'll show you an example in a second, it's more complicated, be sure to, number one, follow all order of operations when you're solving it. And you must isolate, which is kind of the same thing. I'm saying number 1 and number 2 are kind of the same. Isolate the log expression first before you flip it into that exponential form. Let me show you what I mean with this example here. So here we have y equals 1/2 log of x minus 8. All right, the argument for the log function is just x. And important to note that when you don't see the base written, I'm sure you recall that the base is 10. Okay, so let's keep those things in mind. Let's switch x and y first. All right, so x, oops, wrong pen, sorry. X equals 1/2 log y minus 8. All right, so there's the switch of x and y. Now, we got to follow order of operations and isolate that log expression first. You see that it's multiplied by 1/2, and then from it we are subtracting 8. So we want to reverse order of operations here. I'm going to add 8 to both sides first. All right, and then we'll deal with that 1/2. And the way I can get rid of that 1/2 is by multiplying both sides of the equation by 2. 2 times 1/2 equals 1. So I can multiply the left side by 2, which would give me 2x plus 16 equals log base 10 of y. All right, and now the log expression is isolated, and now we can flip it into that exponential form. So the base 10, all right, is right there, kind of hidden. So it'll be 10 to the power of 2x plus 16, and that equals y. And right there, we actually, just by doing that, we're all done. Y is now isolated, so that's our exponential function right there. That's the inverse of what we started with. Okay, I hope that was helpful.